Hi there, today we're going to discuss scale drawings and models. Objectives and standards. Today we're going to use scale drawings and then we're going to construct scale drawings. Our standards are 7.G.1. Vocabulary you're going to need to know today is scale drawing, scale model, scale, and scale factor. Use scale drawings and models. A scale drawing or a scale model is used to represent an object that is too large or too small to be drawn at actual size. The lengths and widths of objects on a scale drawing or model are proportional to the lengths and widths of the actual object. The scale is determined by the ratio of a given length on the drawing or model to its corresponding length on the actual object. Consider the following scales. 1 inch equals 3 feet. That means on a map or a drawing or a plan, 1 inch is going to equal the actual distance of 3 feet. 1 centimeter equals 2 millimeters. 1 centimeter on a map or a drawing is going to represent an actual distance of 2 millimeters. Scales are written so that the unit length on the drawing or model is listed first. So the first number that you're going to see is the model or the drawing or the plan, and the second one is going to be the actual representation of it. How to find scale factor. So the first thing we're going to do is set up a proportion, and let's not forget our units, of the model over the actual equivalent to 1 over x. And then step 2, we're just going to solve the proportion. So I'm going to start with my first example. It says, suppose a model of a dragonfly has a wing length of 4 centimeters. If the length of the insect's actual wing is 6 centimeters, what is the scale of the model? So the first thing we're going to do is we're going to set up a ratio of the model over the actual. So I'm going to set up 4 centimeters over 6 centimeters. And our goal is to find out how much does 1 centimeter actually equal. So we're going to put an X down here. Next thing we're going to do is we're going to solve the proportion using our cross products. So we're going to multiply 4 times X and then 6 times 1. Now that we have our cross products, we can multiply. So 4x equals 6. Our variable x is being multiplied by 4. So I'm going to divide by 4 on both sides of the equation, and I get x equaling 1.5. And that's going to be in centimeters. So our actual scale is going to be 1 centimeter equals 1.5 centimeter. Here's another example. A model car is 4 inches long. The actual car is 12 feet long. What is the scale of the model? So here we're going to again set up model over actual. So we have 4 inches here, and it actually measures 12 feet long. Okay? So now we're going to set that equal to 1 inch. So we want to know, what is the scale? If I had the actual plan or the actual model, what does 1 inch actually equal? I'm not concerned with 4 inches, I'm concerned with 1. So now I'm going to set up my cross products. So 4 times x, and then I have 12 times 1. So now that I have my cross products, I'm going to multiply them out. 4x equals 12. Now that my variable x is being multiplied by 4, I'm going to divide by 4 on both sides of the equation so that I can solve it to x equaling 3 feet. So our scale is going to be 1 inch equals 3 feet. Here's another example. Example number 2. The blueprint of a skateboard ramp shows that its length is 11.4 inches. If the scale on the blueprint is 1 inch equals 6 feet, what is the length of the actual skateboard ramp? Again, we're going to start setting up our ratios, and here we actually have a plan in front of us. So we're going to set up the ratio plan over actual. So on the plan, the blueprint, it shows that 11.4 inches is actually equivalent to an unknown value. That's what we're going to find out. So on the plan, we know that 1 inch equals 6 feet. So 1 inch, forgot that there, equals 6 feet. Okay, now that we've set up our proportion, we can now solve the equation. So we have 1 times x, and then we have 11.4 times 6. So here we get 1x equals 68.4. Our unit is going to be in feet. So that means that the actual length of the skateboard is 68.4 feet. So the actual ramp is 68.4 feet. Here's a second example for you. A map has a scale of 1 inch equals 8 miles. Two towns are 3.25 inches apart on the map. What is the actual distance between the two towns? Okay, so we're going to set up our ratios, map over actual. Okay, so here is our scale that it gives us. So on the map, 1 inch equals 8 miles. We're going to set that equal to another proportion. The other information we were given was 3.25 inches, and that's on the map. So we're going to put 3.25 on top, and we don't know how many it actually is, so we're going to put an X there. So now we can set up our cross products. So 1 times X equals 8 times 3.25. All right, now we're just going to multiply that out. X is going to equal 26 miles. So the distance between the two towns is 26 miles. Okay, now we're going to have an example about something a little more common, and this is actual like blueprints, finding the dimensions of a room. So Lila's painting a mural at the community center on a wall that measures 18 feet long and 12 feet tall. Make a scale drawing of the mural and use a scale of 1/4 inch equals 3 feet. Use a 1/4 inch grid paper. So here I'm actually just going to go over how to find the dimensions, and then you can kind of draw them later on your own. So what we're first going to do is we're going to identify the scale. So the scale is 1/4 inch equals 3 feet. Okay, so now our first step is we have to find the new length and we have to find the new width. Okay, so we're first going to start with our length. Okay, so how do we know which one is length and which one is width? Length we're going to have is the one that has the word long next to it. So we're going to have we're going to have map over actual. And you can call it model over actual, plan over actual, whichever makes you more comfortable. So we have 1/4 inch over 3 feet, okay? And we want to know on a scale, we don't know what it is, if it is 18 feet long, okay? So now we can set up our cross products. So 3 times x equals 1/4 times 18. All right, and if we start solving that, we get 3x equals 1/4 of 18 is going to equal 4.5. Okay, so when we start doing this, we're going to divide both sides by 3 so we can solve. All right, and so x is actually going to equal 1.5 inches on the map. So if we're going to draw this on paper, we know that the length needs to be 1.5 inches. Okay? Now that we found the length, and I'm just going to put length over here, we're going to go and try to find the width. Okay? Now if you look back at our example, the width was 12 feet tall. Okay, so we're going to basically do the same thing we did for the length, except instead of writing 18 feet, now we're going to write 12 feet. So again, we're going to write map over actual. So it's a 1/4 inch over 3 feet, equaling, we don't know yet, and again, we said that the width was 12. So we're going to put 12 feet here, and we're just going to set up our cross products and start solving. So here we go, 3 times x, and then we have a 1/4 times 12. So we have 3 times x is 3x, and then a 1/4 of 12 is 3. Now x is our variable that's being multiplied by 3, so I'm going to divide by 3 on both sides. So x is going to equal 1 inch. So if you're going to actually draw this, the dimensions of the room is 1.5 inch by 1 inch. So when you draw it, you're going to draw the length 1.5 inches and the width 1 inch. All right, I'm going to just do one more example with you before we say goodbye. So Sheila is designing a patio that is 16 feet long and 14 feet wide. Make a scale drawing of the patio. Use the scale 0.5 inches by 4 feet. Okay, so that is our scale right there. So we're going to do this rather quickly, so we should be a pro at this. So we're going to start off with our length. Again, that is where it says long. Okay, so we're going to do map over actual, and that is 0.5 inches over 4 feet, and that equals, we're not really sure yet, but we know that it is 16 feet in real life. Okay, showing our cross products, we have 4 times x equaling 0.5 times 16. So now we have 4x equals 8. Now we're going to solve for x by dividing by 4 on both sides because x is being multiplied by 4. So x is going to equal 2 inches. So our length is going to be 2 inches on our map. Okay? Now we're going to work on the width on the other side. So again, we're doing map over actual. So we have 0.5 inches over 4 feet. And that is equal to, I'm not really sure yet, so I'm going to call it x. And it's 14 feet wide. So 14 feet. Now we can set up our cross products. We have 4 times x equaling 0.5 times 14. So 4x now equals 7. Now because x is being multiplied by 4, I'm going to divide by 4 on both sides of my equation. So x is going to equal 1.75 inches. So the dimensions, again, are going to be 2 inches by 1.75 inches. Okay? All right. So today we used scale drawings and constructed scale drawings. I really hope that video was helpful. Thank you. Bye.